Welcome to this video on exponent laws. In case you don't know exponents, let's suppose that we have 2 to the 4th power. So now this, literally, this is what it does not mean. It does not mean 2 times the result of 4. So that is not even true after all. So this does not mean that. So what it actually means, this is what it means. It means 2 times 2, 4 times each. So that is the result of that. So that means each number is going to be 2 times 2 times 2 times 2. So that is the result of 2 times 2 times 2, or 2 to the 4th power. So that is what it means, the same thing. Now, remember what I said at the start of this video, that there is going to be laws to it. There is laws to this thing called exponents, but I am going to start out simple. If you are new to this, exponents are mostly described as repeated multiplication. So I'm gonna write that down. So hang on. So it is classified. So I will write this down. Exponents is mostly classified as repeated multiplication. But I'm just gonna type it out there. My writing skills, it totally sucks. Definitely, it totally sucks. So I'm just gonna type it out. So repeated multiplication. Okay, so I'm not even sure if I misspelled that. Oh god. Okay, so exponents are mostly classified. So they're mostly classified as repeated multiplication. And that is what you are actually literally going to get. Repeated multiplication entirely. So let's start with another example. I can just move right over here. Let's suppose that we have 2 to the 3rd power times 3 to the 2nd power. Now, what will this answer even equal? So, and you literally might find this tricky. Actually, super tricky for starters here, but look, we can simply simplify this by adding the exponents. So, we would have added 3 and we would have added 2. So 3 plus 2 is just going to be 5. So and then we can multiply the exponents 2 and 3. So the result is just going to be I'm trying to select the color. So the result is going to be 6 to the power of 5. That is our answer over here for this question. So the answer, okay, what in the world am I even doing? No, I should have prepared this out. Okay, great, so I'm just gonna erase this. Okay, so it was okay, why am I even laughing out loud? I know it's kind of dumb for me to laugh out loud, but I'm just gonna go with it. My bad. Anyway, so the result is just going to be 6 over 5, and 6 to the 5th power. I'm just gonna put that on the calculator. Okay, alright. So 6 to the power of 5 is going to be 7,706. So 7,776. And that is your result over here. Now let's move on to, okay, you know what? Let's just actually kind of like continue. Now you could asking like what kind of law it is actually. Well, this is all I could say. This is what I like to call a, oh man, why did they have to pause this thing? Like, okay. So this is what I call a power of a power. So a power of a, oh come on, of a power. And there you go, power of a power. So that's where you got like 2 different powers and 2 different bases. So this is actually, the solution is you have to add them up one by one, and then the second goal is you have to multiply the exponents, and that is your result, and you get your answer. So let's move on. Let's try something different. Let's say that, I'm just gonna put it over here. Let's say that I got 5 to the 1st power. And you won't believe this, but you won't believe this. 5 to the 1st power is just going to be the same number, 5, and it's kind of like mysterious, but remember what I said is that right over here is that 2 over 4. What I really meant was that exponents are mostly repeated multiplication. But, in reality, you're actually multiplying. It kind of like sounds like you're multiplying by 1. It kind of like sounds like you're doing 5 times 1 as the result. And, it's actually kind of like strange and kind of like peculiar, but this is what all I gotta say that, well, it's just math. It's just math. That's all I could say. But anyway, thank you so much for watching, and I know that it's kind of like badly done, but needless to say, I wasn't even prepared. I gotta say, this is really my first ever screencast that I have used. So this is what you definitely get. But this is all I gotta say is, well, see ya. And all I gotta say, I want you